Hey there, folks. Welcome back to Fact with Nandiwal 2.0. Today, we're diving into a fascinating topic that'll leave you wide awake and craving more. There are so many questions that we have about the beginning of the universe, what started it, what was there before the Big Bang, and exactly how old is the universe. The last question, scientists feel pretty confident that they know the answer. Current estimates suggest that the universe is around 13.8 billion years old, but it turns out that estimate could be very, very wrong. With some recent shocking James Webb Telescope discoveries, a brand new study suggests that the universe could be twice as old as we previously thought. The universe could be 27 billion years old. So today we're going to explore the details of this new study, the discoveries that led to our understanding of the age of the universe in the first place, and how cosmology will completely change forever if this new estimate of the universe's age turns out to be true. The age of the universe has been one of the most hotly debated questions throughout history, even within the scientific community. But now most cosmologists agree that the universe is around 13.8 billion years old, with an uncertainty of less than 1%. The time the universe has been expanding after the Big Bang. This number is typically determined in one of two ways. The first way is to measure the rate of expansion of the universe using the Hubble constant, the method used to measure the rate that galaxies are moving away from us, and inferring how long it took them to get there. The other method is to study ancient stars in the universe and things like globular clusters. Scientists are able to study things on these ancient stars like brightness, color, and rotation rate to determine its age to a high degree of certainty. By doing this, astronomers can say that there is a minimum age to the universe. Both of these methods lead to overwhelming evidence that the universe is 13.8 billion years old, give or take around 21 million years. Not only that, but this age estimate works nicely with the countless other observations and models about the universe today, namely the signatures from the cosmic microwave background radiation, the earliest known light signatures that we've captured of the universe after the Big Bang. However, while these estimates fit nicely into these current cosmological models, it doesn't explain everything astronomers have observed in the universe to date. There are some things that go against this estimated age of the universe, some discoveries that seem to completely contradict and break our understanding of the universe. Possibly one of the largest contradictions to date is a star called Methuselah. A paper published in 2013 estimated the star to be 14.5 billion years old. The star is somehow older than the universe. This is a common topic that Big Bang deniers like to point to as a fatal flaw in the theory, and while the existence of this star may sound entirely contradictory to the Big Bang, there is one thing that those Big Bang deniers tend to ignore, and that is certainties. The more precise estimate of the Methuselah star is 14.45 billion years old, with an uncertainty of 0.8 billion years. As time goes on, those measurements become more and more precise, but this is just the current estimate that we have to date. Now, if you assume the max uncertainty of that 0.8 billion years old, the star falls within the current age of the universe, putting it around 13.65 billion years old. But if you take the uncertainty in the opposite direction, the star clearly falls far outside of our current estimates. This creates a huge problem for the current cosmological models. Another more recent problem that astronomers have had to deal with is this discovery from everyone's favorite new telescope, the James Webb Telescope. It discovered a group of galaxies that were estimated to have formed only around 300 million years after the Big Bang. While this does fall within the current estimated age of the universe, the young age of these galaxies does not everything that we thought that we knew about the formation of galaxies this size told us that it wasn't possible for these galaxies to exist. They were much further along in their formation than thought possible at that point in the universe. Somehow they were able to survive the massive amounts of radiation and collisions from other stars or galaxies. This is why these types of galaxies came to be known as the impossible galaxies. The general thought from these findings was that cosmologists needed to revise their models on how galaxies formed in the early universe, or that these findings by the JWST are somehow a mistake. But what if they're not? And what if we're wrong? What if these stars and galaxies are trying to tell us that our timeline of the universe's age is completely off, and we're all just unwilling to accept it? Foreign by a physicist out of the University of Ottawa named Rajendra Gupta proposed a controversial theory that we are very wrong about the age of the universe. His paper suggests that the universe is about 26.7 billion years old. So where did he come up with this number? In order to do this, Gupta had to challenge quite a few ideas and methods on how we currently determine the age of the universe, as well as how we measure light from ancient stars and galaxies. His largest and perhaps most controversial challenge is that he states that we're misinterpreting the data that we see from the redshift of light from distant stars and galaxies. Redshift was discovered by Edwin Hubble and is what happens when light shoots further towards
This was a theory that Swiss astronomer
Wiki came up with back in 1929. He proposed that light lost energy over time as it traveled across the universe. His theory was later largely rejected by the consensus of the cosmological community, as it contradicted much of the accepted standard cosmological model of the universe. But Gupta states that the tired light theory can in fact work if you add in what's called the varying constants hypothesis, which is originally proposed back in 1939. This hypothesis states that the interaction between particles throughout the universe doesn't remain constant at all, rather it varies and changes over time ever so slightly. These variables are things like strength of forces and mass of particles throughout the age of the universe. And again, like the tired light theory, this high hypothesis was largely challenged by most scientists, but Gupta states in his paper that while individually each of those ideas don't work, if you combine them, that can actually reconcile the issues of the tired light theory and have it fit into the standard cosmological model quite nicely. Gupta claims that his new model explains away some of these cosmic mysteries about the early universe. It allows for stars like Methuselah to have had time to form and exist within the universe. It also allows for an explanation as to why these impossible galaxies that JWST is discovering are so old, and why they're so small and compact. Gupta also claims that the Hubble constant, which scientists use to lay out how dark energy is driving the expansion in the universe, isn't completely accurate. With all these together, and taking into account the varying constants, Gupta arrived at a new calculation for the age of the universe, 26.7 billion years old now. Clearly Gupta's new suggested model goes against much of the standard cosmological model, but this wouldn't be the first time that our understanding of the universe has been challenged throughout history. Sometimes these seemingly outlandish claims turn out to be correct. So what if Gupta turns out to be right? What does that mean for our understanding of the universe? The first and most obvious side effect of all of this would be that scientists would need to revise the majority of the models that are based on a younger universe. It would be a relatively scary yet exciting time in cosmology. It would once again bring up old questions that we thought were previously answered, questions like how the Big Bang actually started, how will the universe end, what was there before the Big Bang, and whether or not the universe is finite. Current understandings of the universe show that the universe is infinite and uniform, but what if that wasn't true? Is there an edge to the universe, and more importantly, what's beyond that edge? And while it's not presumed that many of these questions will lead to different answers than what we already have, however, it would create a need for cosmologists to revisit those questions. The other question you might be asking is, what's the likelihood that Gupta's findings and paper is correct? Well, currently that's unknown, but what we do know is that it does go against many of the current accepted models that we have about the universe, and it also requires many of those models to be completely thrown out. This is a massive obstacle to overcome. Now the scientific process will do what it does best. It will observe, test, and verify. Gupta's proposal will need to be scrutinized by the scientific community, and the determination as to whether or not his research is correct is probably still a ways off. So I'd like to ask you, what do you think? Is it more likely that these measurements of ancient stars and galaxies are incorrect or flawed, or is our fundamental understanding of the universe's age completely off? Is the universe really 27 billion years old, or is this just an example of a physicist trying to answer unsolved mysteries about the universe and getting a little too carried away? If you find the information valuable and enjoy our content, we kindly ask for your support by liking and subscribing. As a new channel, your trust means a lot, and every like is greatly appreciated in creating more videos like this.